Hello, my name is Ostap. This video is done for assignment 5. So in my model.h, I have a model class that has protected member data, which is my vector. For the public members, I have a default constructor and the function forward. In the model.cpp, I have my default constructor that sets weights with 1.0. For the forward function, I create the vector. That's my result, where I'm going to keep all my result. Then I create a copy. Since it's a constant function, I cannot modify the weights vector. So I'm going to create a copy. If needed, I'm going to resize it. And then for the result, I'm going to take input and multiply it by my weights. In the linear layer, I have a private class which includes input size and output size. Also, I have vector bias. For the public members, I have my constructor with input parameters. Then I have a forward display size and set flat weights functions. In the linear layer.cpp, I have my constructor with parameters that takes in input size and output size. Also, it uses a resize function from the model.cpp. I'm able to do that since I include module.h in my linear layer.h. Here for the function forward, first what I'm doing is I'm checking my input vector. So if it does not have the correct number of elements, I'm just going to return the empty vector. And if everything is fine, then I'm basically taking bias, put it into sum, and then multiplying the matrix. So like matrix multiplication with bias addition. And then I'm just returning the output, which is a vector that stores all those elements. For the function display, it's basically just a cout function. It has some text and just I cout input output bias in form of B and weights in form of W. Then for the size function, it's basically also a cout function, just it couts input and output size. Set flat weight, basically what it does, it checks if new weights and like weights.size have the same number of elements. If it does not, it just returns. It does not change anything. And if everything is fine, then I change weights to new weights. For the ReLU activation, I have public class, which includes the constructor with parameters. Then I have three functions: forward, display, and set weight. In .cpp, I have my constructor, which basically takes a positive slope and negative slope and creates weights. For the forward function, first what I do, I create an output vector. Then I check for the weights. If I don't have the first element, I set it to 1. If I don't have the second element, I set it to 0, and that's be my positive and negative slope. And here, if input is greater than 0, then I multiply it by positive slope, and else I multiply it by negative slope, and then just return the vector. For the ReLU activation display, I just basically do the cout of my weights. I think this one is a positive, positive and negative slope. Then for the set weights, I basically have a vector of 2 elements for negative and positive slope, and if it does not equal 2, then I return nothing changes. And if there's 2 elements, then I set my old weights to new weights. For the block.h, I have private members, which is a linear layer and ReLU activation, and the public members are my constructor, forward function, display size, set weight, and set activation weights functions. In the block.cpp, I have my constructor with the parameters that basically takes the linear for the linear layer with two parameters, input size and output size. For the ReLU activation, it just uses the default parameters, which was 1 and 0. In the forward function, what I'm essentially doing is I'm calling the linear layer like forward function. Then I take that output and put it inside of ReLU activation forward function, and then that's my result, return the result. For the display function, I call on linear layer display function and ReLU activation display function and just do the line. For the size function, I just print the linear layer size. For the set weights, this one is set weights for the linear layer, and this one sets weights for the ReLU activation. For the neural network.h, we have the private member, which is just my vector blocks. For the public, we have a constructor, and we have 5 functions: forward, print model, print block sizes, set block weights, and set block activation weights. For the .cpp file, we have a constructor here. So what it does, basically, if we have only one number of blocks, the architecture would look like input and then output size. If we have 2 or more blocks, then basically everything in the middle is going to be hidden. I call it first cut. For the in place back, basically I'm deciding where the first cut is going to happen so I can get rid of the hidden sizes. Then for the last cut, I also calculate where the hidden size, like the last one, is, so I can just have input size, output size. So basically, if we, for example, have like 4 blocks, then it'll go from first to the output, from the input to output, and like everything in the middle is going to be hidden. And here I'm looping through all the blocks so I can get my output. For the forward, what I'm doing here is I'm basically calling a forward function of the block.cpp, which is like right here, and this one is calling on linear layer and ReLU activation. So what's happening is I'm looping through it so I can get my result. So first it's taking the output and putting it for the linear layer, and then putting it in a ReLU activation, and then I get my output, and then I return it. For the print model, I also have a loop here, so it loops through all the blocks and just prints them all. For the print block sizes, basically the same is happening. Not actually. For the specific index, no, this one goes through all of them. The set block weights changes the linear layer weights for the specific block. So I take the block index and change that particular linear layer weights. And basically the same is happening for the set block activation weights, but it changes block ReLU activation weight for the specific block. But it checks if that vector is a valid one. And when I try to run it, I just do make, it's up to date, then I just run the executable, and that's my output. Thank you for your attention.